All right, everyone. I guess we are live now. So, good evening, everyone. So, just write a quick +1 if I am audible. And yeah, just write a quick +1 in the chat so that we can start the discussion. Cool. So, myself, Ayush Tripathi. Currently, I'm working as a mentor and the problem setter at Geeks4Geeks, and welcome you all to this post analysis session of the last weekly contest 177, I guess. Yeah, 177. So before starting the discussion, I wanted you guys to rate the entire contest on a scale of 10 so that would help us to improve the upcoming problem set. And how was the problem and how many problems you were able to solve? Yes, I also personally categorize this entire contest to bit harder side than the usual contest. But all the four problems were very easy. But the last problem was the most difficult problem of the contest. It uses the advanced concept of segment tree with a lazy propagation, which is an advanced topic. But the first three problems were really very amazing, and every problem has some unique learning. Cool. So let me just share my screen. Yeah, for the last problem, the prerequisite is a segment tree. So if you have not know about the segment trees, then I recommend you can skip the last problem especially. So let's just start with the discussion. So starting with the very first problem, which is a pretty easy and uses a very standard technique of sliding window. So let me just change the template. Which one? Yeah, this one looks better. So the most easy problem of the contest. Geek has a string str. Just 1 minute. Cool. So Geek has a string str of lowercase letters, that is from small a to small z. Only 26 letters will be there, and an integer k. He wants to find out the substring of length k with the lowest score, and the score of a string is the sum of the sky value of each character present in the string, and help him to find out the substring with the lowest score. And if multiple substring have the same score, then we have to select that one with the smallest starting index. Cool. So for this particular string hello, we need to find the length of we need to find the smallest substring of length 2, that is length k, with the lowest score, and its score is basically the sum of sky value of the character present inside it. So this is the first substring of length 2, and its score is 205. Then the second substring el of length 2 with the score 209. Then the third one with the score 216, and finally this one, last one, of length 2 lo with the score 2 1 and 9. So here among these score, the lowest score is 205, which is from this substring he. So that's why here the expected output is a substring he. So let's see how we can solve this problem. So this time we don't have to return the length, but instead we have to return this entire substring. So for that thing, what I can do, I can store the starting index of the best substring. Once I know the starting index of the best substring, so from that starting index, I can return the k characters. So let's say you're given a string is what we can say. Let's say geeks for geeks. So let me write the indices also. So index 0, 1, 2, 3, 4, 5, 6, 7, and basically so on. Cool. So let's say the value of k is 3. So this is a problem which can easily be solved with the help of a sliding window. And this is a variation where the length of size of the window is 6. So all the sliding window problems can be categorized into two categories. The first one where the window length is fixed. So fixed length window. And the second variation of the sliding window problem where the window length is not fixed. Window is not fixed. So this is the problem of first type where the window length is fixed. So what I can do, I can first find the answer for the first window of length k. Then I will move this window. That is first it is storing the substring, first substring of length k, then second substring of length k, then the third substring, and so on. And there are limited number of changes that we have to do to shift the window. So let's see what are the changes that we have to make. So index 0, 1, 2, 3, 4, and 5. So I can simply find the answer for the first window, that is first k characters. So let's say the variable current will store the score of the substring, and this window is just an imaginary term. We use a variables to keep track of the window. So first of all, we have a variable current that will store the score of the window, that is the score of the substring. It basically the sum of sky value of all its character. So just iterate over all the characters from 0 to k minus 1, k characters, so 0 to k minus 1, and the current plus equal to s of I. And this thing is called as implicit type conversion. The character will be converted to an integer, and that integer will be its sky value. So this is for the first window, and then I have to shift the remaining window. So basically from first window, from the first substring to the second substring of length k, then the third substring of length k, and so on. So what are the changes that I have to make? So let's just observe the changes. So this is my first window, and if I want to shift this window, that is from this red color window to the green color window, then what are the changes that I have to make? So I have to delete this character from the window, that is last character of the previous window, and I have to add one more character. So can I say this thing? I iterate over all the characters, all the integers from I is equal to k, and here I is the ending point of the window, of the current window. So from k to n minus 1. Cool. And basically this is a very generic formula that we use to solve all such problems where the length of the window is fixed. So the first step is to remove the contribution of the last character of the previous window. So can I say this thing? This will be my first step. So here I will just simply remove the contribution of character s of I minus k. So basically 3 minus 3, which is equal to 0. This is same as our required index value. I want to remove the character which is at index 0 from the current window. So remove s of I minus k from window, that is subtracts this sky value from the variable current from window. Then the second step is to expand the window, that is add the contribution of character s of I, which is 3. Cool. And then the third step is to update the answer. If the score of the current substring is lesser than the previous score that you have. Cool. So here I can just simply say if I remove the contribution of index 0, so this is the substring, and if I add the contribution of index I, so that is a 3. So I can just simply say my previous window is now converted to this one. That is, I have shifted this window by one position to the right. Cool. And in the next iteration, the value of I is 4. So I will add this character, that is character which is at index 4, and I will remove the character which is at index I minus k, that is 4 minus 1, which is 4 minus 3, which is equal to 1. So it simply means I have shifted the window by one position. So this is the complete approach. Is it clear to everyone? Just write a quick +1 so that I can show you the implementation. And it will take order of n time because each and every index we are visiting exactly one time. So just write a quick +1 if the approach is clear to you. And make sure to note down these 3 steps of all the problems of type 1 of sliding window. What about the other participants? Is it clear to you or not? Cool. So I guess it is clear to everyone, I wish. So yeah, here is the implementation. This is the class which is given to you. And you have to complete this method. So string str, then integer k, that is length of the window. Then first I have taken the length of the string, and then this is for my first window of size k, that is all the indices from 0 to k minus 1. And this is my current sum, that is sum of sky value of the character which is in the current window, and this is minimum sum that I have so far. So first of all I will initialize this minimum sum with the current sum because there might be the case when the first substring of length k has the lowest score, and its start index is index 0. And once I know the start index, then I can just simply return k characters from here. Then I iterate over the remaining windows, that is index k to n minus 1, and removing the contribution of last character of the previous window, that is s of I minus k, then adding the current character s of I, and if the current score is lesser than the score that we have so far, then I will update my answer. So start is equal to I minus k plus 1. I minus k plus 1, it simply means a starting index of the current window, and then I will update this minimum score that we have so far with the current score. Cool. And once I know the start index, then I can just simply return the k substring of length k from here. So yeah, this is the complete implementation for the first problem. Now let's just move to the second problem. Valid queries 1. And valid queries 1 and valid queries 2, both are the two amazing problems of this contest. And especially for the beginners, it uses some very standard technique that would help you to solve more such upcoming problems. So yeah, let's just start with the very valid queries one. So Geeks loves playing with the strings, and he has a two string text and pattern. He perform queue independent queries on the text. That is, every query is independent of each other. If you perform some query, and before moving to the next query, delete all the changes because of the current query. So in each query, he changes all the characters of the text from index L to R. Both are inclusive. Index L to R to asterisk. Cool. And he want to know the count of valid queries. And a query is a valid if the permutation of the characters of the pattern string occurs in the text string after performing the queries. And we need to help him to find the count of valid queries. So let me explain you the first sample input, then the problem would be more clear to you. So before discussing this sample input, let's just first analyze the constraint. So both the string length can be up to 10 power 5, then the number of queries can be up to 10 power 5 also, and the value of L and R, the value of R is always greater than or equal to L, and also greater than 0 and less than the length of text string. That is, zero based indexing has been considered, and both the strings contain lowercase English letters, that is only 26 possibilities. So yeah, let's just solve for the first sample input. So let me write the indices too. So this is index 0, then index 1, index 2, 3, 4, 5, and 6. How to come up with the optimized approach for the second problem? So for this thing, there is no alternative. You must have to give as many contests as you can. There is no alternative of practicing the problems. So make sure to remember all the techniques that we're gonna discuss in this stream, because all are some very standard technique. Cool. So the first query, which is from 1 to 4, that is from index 1 to index 4, we have to replace the characters with the asterisk symbol. So replacing the characters with the asterisk symbol is very similar to the deleting the substring. The substring which it starts from index L and it ends at index R, because we have to change the substring characters to the asterisk symbol And this pattern string will not contain an asterisk symbol. It only contains the characters from small a to small z. So I can just simply say that performing some query simply means deleting some substring from the text string. So let's just delete the substring from 1 to 4. That is these many characters. And now we have to check whether in the remaining string, in the remaining text string, we have all the characters with a greater or the same frequency as in this this pattern string. So here basically you have to check for the permutation, and I can just simply say this thing, that is all the characters of this pattern string must be present in the text string with any permutation. So very similar. If I this is very same. If I say all the characters must be present, all the 26 characters must be present with at least required number of frequency. Cool. So here this query is not valid because here we have a frequency of a as 2 in the remaining string, then the frequency of b as 1, then the frequency of c is 0, but the required frequency of c is 1. So this query is not valid. Then let's just move to the second query. So the second query from 1 to 2, that is from index 1 to 2, these two characters. And in the remaining string, we have the frequency of A as 3, frequency of B as 1, and the frequency of C as also 1. So we have all the characters with the required minimum frequency. And we can basically here we require the frequency of A as at least 1, then the frequency of B at least 1, and the frequency of C at least 1. And it meet all my requirements. So that's why this is the query which is valid. Cool. Now let's just finally test for the last query, which is from 0 to 6. That is all the characters. I will change to asterisk, and we don't have any character. That is all the character has frequency 0. So this query is not valid. So I hope at least the problem statement is clear to everyone. And here the number of valid query is 1. So that's why in this case my expected output is 1. The number of valid queries. Cool. So let's see how we can solve this problem. This problem can be solved with the help of a prefix and suffix technique. So let's say we have a text string. Not exactly the sliding window, but the prefix and suffix technique that I'm going to use is very similar to the sliding window. So let's say we have a text string, and let me write some characters here. Hashing technique can be also used. Yes, you can also use hashing. That would also work. But polynomial hashing will work or not, it depends on a test case, because hashing technique is a probabilistic model. It may have some failures depending on the problem setter and the test cases. So A, let me write some random string here. And also let me write some pattern string. So let's say we have A, B, and C. So index 0, 1, 2, 3, 4, 5, then 6, 7, 8, and 9. That is a text string of length 10. Cool. So what I have to do, let's say we are given some query, that is a query of some query which starts from index 3 and it goes to index 7. That is this is the value of L and the value of R. Cool. That is we have to delete this substring from 3 to 7. Value of L and the value of R. And in the remaining substring, in the remaining string, which is sum of its prefix and some suffix, in the remaining string, I have to tell whether we have all the characters with same or the greater frequency as in this pattern string. So how we can find the frequency of all the characters in the remaining string? So this problem can be easily solved with the help of a prefix and suffix technique. So let's just first declare an array. So let's say the array prefix. You don't have to use another special array for the suffix, because from the once I get the frequency of characters in the prefix, then I can easily find the characters frequency of the character in the suffix by using just some mathematical operations and a mathematics operator. So let's say prefix of I comma j. This is a 2D array, and this will simply store the frequency of character j, and obviously this is character j, and the sky value of j. This j simply means the sky value minus a, and this is simply called as the ordinal number. Very straightforward thing. That is, I will convert every character to a integer, and that integer I will use as an index. That is, I will map 0 with the character a. All the characters will be a lowercase, so we don't have to worry. Only 26 possibilities are there. Then I will map character b to index 1. Then I will map character c to index 2, and so on, index 25 to the character z. Cool. So this z is a ordinal number, is a index value to which I will map the character. And how I get this thing? So this is simply ordinal number. Ordinal number that I can easily get from by subtracting a from here. So ch minus a. This is the formula that I can use to get the ordinal number. The sky value of the current character minus the sky value of character a. Cool. So prefix of ij will simply store the frequency of character j in a prefix or in a substring from 0 to I of the text string. So text of 0 to I. Cool. In the substring from 0 to I, this prefix of ij will simply store the frequency of character j in the substring 0 to I. Cool. And what will be its maximum size? So here the size that I will use is n cross 26, because 26 characters are there, and n indices will be there. And then for every character I have to check whether its frequency is greater than or equal to the required frequency. So I will use one extra array of size 26 for this frequency, for this pattern string. So let's say the name of the array is frequency, and it will be of size 26. Here I will store the frequency of all the characters of the pattern string. So for this particular example, the frequency of a, I'm talking about this pattern string. So for this particular example, I will just simply find the frequency of a, which is equal to 1. Then the frequency of b, which is equal to also 1, and then the frequency of c, which is also equals to 1. Cool. Now in the remaining string of this text string, I have to check whether we have the character with the same or the greater frequency. So for this thing, let's just simply find the character of frequency of a character j, some random character j. So frequency, I can write in this way: frequency of character j in remaining string remaining string in the remaining string. So how we can find this thing? So this can be easily find with some mathematical operation. So let's say it is a current, and it is simply equals to prefix of n minus 1 and j. So what does it mean? It simply means this entire string. What is the frequency of j in the entire string? what is the frequency of j in entire string, that is from in a substring 0 to n minus 1 or entire string. Cool. Index 0 to n minus 1. And then I will just simply subtract. What I will subtract? Frequency of character j in the substring 0 to r, that is this thing. Frequency of r, that is the prefix of r and j. Cool. That is, I will subtract the frequency till index r, this thing. So now I have computed this prefix part, this suffix part, not prefix. Now I have to add the contribution of prefix, basically this part. So for this thing, what I can do, I can just simply add prefix of l minus 1 and j, that is frequency of j from index 0 to l minus 1, this part. So this eventually give me the frequency of character j in the remaining string. So this I will do for all the 26 character. And yeah, this is the formula. So this is the complete approach. Let me just again summarize what are these steps we have. So first I will declare a array of size n cross 26, and n is the size of this text string. N is the size of this text string. So declare an array of size n cross 26. Then for every character, for every current index I will just simply store the frequency of character j in the substring from 0 to I. And once I know the frequency of all the 26 character in all the substrings, then I can easily check whether the current query is valid or not. So to check whether the current query is valid or not, I will use one extra array, which is a frequency. This is a frequency array. Here I will store the frequency of all the characters of the pattern string. And once I get this information, then I have to check whether the current query is valid or not. And to check this thing, for every character j, and this is from 0 to 25, 0 to 25, that is 26 characters will be there. So I iterate from 0 to 25, and for every character j, I will just simply find the frequency of j, frequency of j, character j in the remaining string of text. And if this frequency is greater than or equal to the required, then the query is not valid. And we have to check for the remaining characters. If it is satisfied for all the 26 characters, then the query is valid. Cool. And if at any point of time you would get that the value of current is less than frequency of j, it simply means if the frequency is less than the required frequency, then the query is invalid. Query is invalid. So just write a quick +1 if this complete approach is clear to you, so that I can discuss the implementation. So let me just show you the implementation. Maybe then it would be more clear to you. So this is the method that we have to complete. This is the size of the text string. Then here I have my 2D array of size n cross 26, and initialize all the values with 0. Then this is for index 0. For index 0, all the character has frequency 0 in the substring from 0 to 0, except the character which is at index 0. And then iterate over the remaining indices and copy all the previous frequency and increment the frequency of the current character. So let me just explain you this part again. So how I will find this frequency of I comma j. So frequency, that is prefix of ij, it simply equals to prefix of I minus 1, that is frequency of character j in the substring from 0 to I minus 1, and then prefix of I, and then the current character. So the current character is s of I, or it is not actually s of I but the text of I. So text of I minus a, and to get this thing plus plus, cool, and to get the index just simply subtract the sky value of a. All right, thanks Gitesh. So then this is my pattern array of size 26 to find the frequency of all the characters of a pattern string. So for all the characters of the pattern string, increment its frequency, and then I have to check whether the queries are valid or not. And if q is the current query, then the value of L, that is basically the range q of 0 and q of r, q of 0 and q of n, n q of 1, and this q of 1 is the value of r, and we have to check whether this current query q is valid or not. And to check this thing, I will iterate over all the 26 characters, that is from 0 to 25, and the current frequency is simply equal to the frequency of j in entire string, in entire text string, then minus the frequency of j up till index r, and if the value of L is greater than 0, then I have to add the contribution of prefix, which is up to L minus 1. We have to add its contribution, and if the current frequency is less than the required frequency at any point of time, then the query is invalid. I will just simply break this loop, and if the query is valid, then increment the answer. So this is a complete solution. Just write a quick +1 if it is clear to you. So this is the prefix array, and the prefix of I, just yeah, just go through this definition. Prefix of ij will store, prefix of ij will simply store the prefix of character j in the substring, basically not prefix but the frequency of character j in the substring from 0 to I in the text string. So what I'm trying to say, prefix of ij, let's say this is index I, so prefix of ij will simply store what is the frequency of character j in this substring from 0 to I. And if you already know the answer for the substring 0 to I minus 1, then just simply copy these values, and add the contribution of the current character, this thing, the frequency of character j is just I'm simply copying the previous values. The frequency of character j in the substring from 0 to I, it is equal to the frequency of character j in the previous substring, and then for the current index, that is text of I minus a plus plus. For the current character, I am incrementing its frequency in the substring. So I hope this thing is clear to everyone. Shall we move to the next problem? And the time complexity is n into 26. N indices 26 characters. This is the time complexity. Cool. So the second problem, valid queries, and the problem statement is again same, but the only difference here, this time the queries are not independent. In the previous version of the problem, all the queries, Q queries, are the independent. That is, you don't have to carry forward the changes. If you have deleted some substring for the current query, then you have to again put back that substring. But this time the queries are dependent. That is, if you delete some substring for some particular query, then it will remain deleted. And now you have to count the number of valid queries. The requirement is again same. The only difference, this time the queries are dependent, not independent. You have to carry forward all the changes that you have made. So yeah, let's just solve the problem. For let me just first explain this test case. So the first query, let me write the indices also. Cool. So let's say index 0, then index 1, 2, 3, or let me just quickly zoom this bit. So index 0, index 1, 2, 3, 4, 5, and 6. So the first query for from 1 to 2, that is, we have to delete this substring, and and after deleting this substring, whether this query is valid or not. And to check whether the query is valid or not, I have to just simply check whether the frequency of all the characters is greater than or equal to the required. So the frequency of character A in the pattern string is 1. That is, this is the minimum frequency that we require. Then for character B, it is 2. Then for characters not 2, but the frequency of B is also 1. Then for character C, it is 1. Cool. So after deleting the first substring, I have to check whether it is valid or not. And here we have frequency of A as 3. In the remaining string, we have frequency of A as 3, frequency of C as 1, and the frequency of B also as 1. So greater than or equal to the required frequency. So this query is valid. Cool. Now let's just check for the next queries. And in the previous problem, I have to revert back all the changes. That is, all the queries are independent. So I have to just again put this substring in the original string. We do not have to carry forward the changes. But this time the queries are dependent, so we have to keep this substring deleted. So then the second query from 4 to 5. That is these two characters. And now I have to check whether it is whether the query is valid or not. And this time the query is not valid because here in this case the frequency of character B is 0 in the remaining string, but the required is 1. So this query is not valid. And then the last query. For the last query, we have to delete all the characters. Basically, we have to replace all the characters with the asterisk symbol. So that's why I'm saying that deleting all the characters. So delete all the characters. Then obviously we have all the character frequency as 0, but here we have required some frequency. So that's why it is also not valid. So in this case, my answer will be equal to 1. Cool. So I hope the problem statement is clear to everyone. Now let's see how we can solve this problem. So I can take this example for explanation. So let's say this is the text string that we have, and let's say that the pattern string is ABC. Pattern string as A, B, and C. Cool. Now just try to pay more attention here. Now I'm going to draw some observation. So what are the observations that we can make here? So every query, let me write some observations here. Observation. The very first observation, every query every query deletes substring of this text string from L to R. Basically, if the query, if q of I, query of I, this is simply li and comma ri. So this query will simply delete the substring from index L to R. This is the first observation. So let's say the first query that is given to me is from 3 to 5. So this query will simply delete the characters, or you can also say that replace it with asterisk symbol from L to R. Cool. And the second observation, which is not observation, but actually it is mentioned in the problem statement, that is queries are independent. Queries are dependent. Queries are dependent. So I have to carry forward the changes. And every query, if every query deletes some substring, then can I say this thing that we are reducing the frequency of the characters? So let's say you have performed the first query, that is you have deleted this substring, and let's say you have performed the another query where you have deleted this substring. So the more number of queries you will perform, the lesser the frequency, the more frequency will reduce in the text string characters. So what I'm trying to say, there is a monotonic predicate nature. So the third observation, monotonic predicate nature, which is a necessary and sufficient condition to apply binary search. Monotonic predicate nature of problem. And what is this monotonic predicate nature of problem? So if after performing the m queries, let's say you have performed m queries. So let's say after performing the m number of queries, your text string is valid. That is, it has all the character with less or greater, with equal or greater frequency. Then if you perform m minus 1 queries, then also the text string is valid. So what I'm trying to say, let's say we have another query which is from 2 to 4. So these are the three queries we have. So in the remaining, now after deleting these characters from here, let me just quickly delete it. This is the remaining string. And for a better explanation, what I can do, I can say this part, because we might have a disjoint substring. So these characters we have active now. Then this one character from here, and basically this character. So instead of saying in this way, what I can do, I can go with this thing. Let's say this is the query. Cool. So now what are the frequency of remaining characters of this text string? So the frequency of A is 3, I guess. Yeah, it is 3. The frequency of B is 1, and the frequency of B is 2 actually, and the frequency of C is 1. Cool. And how many frequency of the characters? How much frequency of the characters we required? So here we require frequency of A as 1, frequency of B as 1, and the frequency of C as 1. So after performing these three queries, After performing these three queries, this is my query 1, let's say. This is my query 1, then this is my query 2, and this is my query 3. After performing these three queries, my text string is still valid. It has the character with the greater or the same frequency. So can I say this thing? If I perform, let's say this is m queries. So if m queries, if after performing m queries, if after performing m queries, text string, or I can say the remaining text string, that would make more sense. Remaining text string is valid, then can I also say this thing? Then for m minus 1 queries, that is after performing for m minus 1 query, the text string, the remaining text string will also be valid. That is frequency same or greater. So if I do not perform some query, then also the text string would be valid, because if you do not perform some query, then it means we are not deleting some substring. So it will give more characters that will added in my remaining string. So is it clear to everyone? Yes? No? Anything? These three observation. Just write a quick +1 if it is clear to you. Cool. So can I say this thing? If my answer is M, or I can also say this thing, that is my answer is simply equals to maximum number of queries after which remaining text string is valid. So since we have a monotonic predicate nature, then I can say this thing. I can simply apply a binary search, that is the value of low, the maximum number of queries that we can perform may be 0, and then high, value of high as q, where q is the number of queries we have. Or I can also say this thing, that is length of the queries array. Cool. And then I will just simply find the value of mid, which is simply equals to low plus high by 2, and dividing it low plus high by 2. And now I have to check whether performing mid number of queries, mid number of queries, text string is valid or not. Text string is valid or not. And if it is valid, then it will be also valid for mid minus 1. Let me write this thing again. So if valid, then also will be valid for mid minus 1, mid minus 1, mid minus 2 up to 0. That is when you do not perform any query. So if you can perform mid number of queries, then and the text string is valid, then it will remain valid if you perform mid minus 1 number of queries or mid minus 2 up to 0. So this is a monotonic predicate function, and now I have to check whether after performing mid queries it is valid or not. So how I can do this thing? So to check, now I have to check the text string, check the text string after performing mid queries, mid number of queries. Now I have to check for this thing, whether the text string is valid or not. So for this thing, what I can do, I can use the technique of a difference array. And it is a very standard technique of solving the array problems and string problem. So technique of difference array. Difference array. So I can explain with an example. So let's say we have a text string, or I can copy the same text string, this one. So and let's say the queries are some queries. Let's say the first query is from index 2 to 3, and then the second query, which may from 3 to 6, or let's say 3 to 5, 3 to 5 only, and let's say the second query, which is from 8 to 9. Cool. So that is, we have to delete this substring from 2 to 3, then 3 to 5, this one, and finally 8 to 9, this one. So for this thing, what I can do, I can use a prefix, I can use an array. So I can use an array. Let's say the array is named as val. So let's say the array is named as prefix, and we'll let you know why I have named this as prefix, because the second step of this difference array technique is to take a prefix sum. So yeah, the array is named as prefix, and of size n, because we have n indices. And what it will do, it will just simply store all the values. Basically all the values will initialize with 0, and prefix of I, after performing all the q queries, prefix of I, if prefix of I value is greater than 0, if prefix of I, first of all I will initialize this prefix of I with 0. So initialization condition, prefix of I with 0, and after performing q queries, if the value of a prefix of I is greater than 0, then it simply means index I index I is part of some query, and we have to delete its character. We have to delete its character. Cool. And to get this thing, that is to update the value of a prefix of I, what I will do, for every query, for every query, for every query L of L comma R, what I will do, I will just simply increment the value at index L, that is the prefix of L plus plus, and decrement the value at index R plus 1, that is the prefix of R plus 1 minus minus. And this is basically step 1. This is step 1. So this is step 1. And the second step is to take a prefix sum. That's why I have named this one as a prefix sum. So this is the first step. Then the second step is to take prefix sum. Prefix sum. That is, I iterate over all the indices. I iterate over all the indices from 1 to n minus 1. And then prefix of I plus equal to prefix of I minus 1. And what is the intuition behind this thing? So let me explain you with the same example. So here the value of n is 10, that is 10 characters are there. The value of n is 10. So this simply means a prefix array of size 10. Cool. So this is my prefix array of size n. And let me just quickly draw the indices. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then initialize all the values with 0. So let me just quickly copy the queries. So the first query was from 2 to 3. The first query was from 2 to 3, then 3 to 5, and 8 to 9. Then the second query 3 to 5 and 8 to 9. So for the first query, basically the first step, I will just increment the value at index L, and I will decrement the value at index R plus 1. This is very standard technique. So make sure to remember this, or if it is not clear to you that how it's working, then you can may watch some videos on YouTube. So the first query from 2 to 3. So that is, I will add 1 and add 1 at index 2. So 0 plus 1, which is equal to 1. Then subtract 1 from R plus 1, that is a 3 plus 1, which is equal to 4. So 0 minus 1, which is equal to minus 1. And let me just quickly explain the intuition here only. So then the next step, this is the first step. The next step is to take a prefix sum. Prefix sum. So this is the second step. So if you take the prefix sum, that is, if you add the value, that is, if you take a prefix sum, prefix of I plus equal to prefix of I minus 1. This is basically simply a prefix sum. So if I add this value to all the upcoming indices, that is plus 1 for here, then plus 1 for here, and then plus 1 and its current value, that is minus 1. So plus 1 and minus 1 will get cancelled out, and eventually you are adding 0 from here onwards. So plus 1 and minus 1, which is equal to 0. So this eventually means you are adding 0 in all the upcoming indices, including the current index 4. And this is something that we want, because the query which is from L to R is from 2 to 3 only. So that's why I have added minus 1. I have added minus 1 at index R plus 1. At index R plus 1, I have added minus 1, so that if I take the prefix sum, then it will get cancelled out. So plus 1 minus 1, which is equal to 0. So yeah, this is the intuition behind this difference array technique. So then the second query is from 3 to 5. So that is add 1 at index L. So 0 plus 1, which is equal to 1. And R plus 1, which is 5 plus 1, 6. So add minus 1 at index 6. So this is minus 1. Cool. And then 8 to 9. So at index 8, I will add 1 here. And 9 plus 1, which is equal to 10. So, but we don't have index 10. So you can check for this condition. If R plus 1 is valid, then only I will update. Otherwise, I will not update. So for this case, we do not have R plus 1. So that's why I will first check whether al plus 1 is valid or not. Cool. And then after performing all the queries, then after processing all the queries, then take the prefix sum, that is add all the previous values. So first we have 0, then it will remain 0, then again remain 0, then it is 0 plus 1, basically current value and previous value, which is equal to 1. Cool. So it will remain 1, then 1 plus 1, which is sorry, this is not equal to 1. This will remain 0 because we have not updated its previous value. So the current value plus previous value, that is 0 plus 1, which is equal to 1. Cool. And then the previous value, which is 1, and the current value 1 plus 1 plus minus 1, which is equal to 0. So this will simply change to 0, same as our requirement. And basically at index 3 we have 1. Sorry, it was my bad. For the second query I have changed its value. For the second query I have changed its value. So 1 plus 1, which is equal to 2, because this index 3 is the part of two queries, one for this one and another for this one. So that's why here we have value 2. Cool. Then at index 4, previous value, that is 2 and minus 1, which is equal to 1. So this simply means it is part of only one query. And then at index 5 we have a 0. So 0 plus previous value, which is equal to 1. So this simply means it is part of one query. Then at index 6, previous value, which is 1, previous value 1, and 1 plus current value minus 1, which is equal to 0. So that's why I have added a minus 1 at index r plus 1, so that it will get cancelled out. Now it is changed to 0, same as our requirement. Then at index 7, we have what we can say. Yeah, at index 7, we have 0. Cool. And 0 plus previous value, which is also equals to 0. So 0 plus 0, which is equal to 0. Cool. Then at index 8, previous value, which is 0, and 0 plus current value, basically previous value plus current value, which is equal to 1. So it will remain 1. Then at index 9, 0 plus previous value, 0 plus 1, which is equal to 1. So this simply change this to 1. It simply means it is part of one query. And basically all the indices which are a part of some, all the indices whose prefix value is greater than 0 is a part of some query. And if it is part of some query, then it is not active in the remaining text string. So then what I will do, I will store the frequency of all the remaining characters. So frequency array of size 26, and it will simply store frequency of characters of the remaining text string. So how I get this thing? So to get this thing, just simply iterate over all the indices. Just simply iterate over all the indices from 0 to n minus 1. And if prefix of I is equals to 0, then it means it is not part of any what we can say. Yeah, it is not part of any query. So this character is active. So increment its frequency. So frequency of s of I, not s, but actually text. So text of I minus a. This is the way to get the index. And plus plus. Cool. So once I get the frequency of all the characters in the remaining text string, then I can easily compare it with the pattern string characters. So this is the complete explanation. And these are basically the mid number of queries. So just write a quick plus one if this part is clear to you. Cool. So let me just show you the implementation here. So here is the implementation for the second problem, for the second version of the valid queries problem, basically the third problem. So this is the method that you have to complete. Okay, not this one, but yeah, this one. This is the method that you have to complete. And here the value of low and high, zero queries or maximum queries that we can perform is q queries. Then my answer is the maximum number of queries that we can perform. And basically this is simply a binary search template. So finding the value of mid, and if we can perform the mid queries, then I will store this answer, this value of mid, and then I will check for the rest of the ranges to maximize the answer. So value of low as mid plus one, and then value of high as mid minus one if this mid is not valid. And how to check? So here I am getting this mid, and then the size of the text string. Then we have this prefix array for our difference array technique, and it is of size n plus one, because r plus 1 may not be valid. So that's why I have declared one extra index, just to be on the safer side. So this is the first step of the difference array technique, that is for every query, and basically 0 to mid minus 1, because we have to perform only mid queries. So value of l and r, then l plus plus at index l we increment the value, and at index r plus 1 we decrement the value. Then the second step, take the prefix sum. Then this is a frequency array of size 26, and I don't have used this variable well, so let's just delete it as of now. Then I iterate over all its indices, and if the prefix value is equal to 0, then it means it is not part of any query. So increment basically add this character. This character is active, and it will not get deleted after performing the mid queries. So increment its frequency, store its frequency in a frequency array, and then here we have this variable is valid. So it simply returns true if the remaining text string is valid. It has all the character with at least frequency after performing mid number of queries. So to get this thing, I will iterate over all the characters of the pattern string, and for every character I will decrement the value, that is decrement the frequency. So that is one character of remaining text string will be mapped with the one character of remaining of not remaining of a pattern string. So that's why for a text string I'm incrementing the value, and for the pattern string I am decrementing the value. So if it is balanced, then it is equal to 0, and if we have more than required frequency, then it is greater than 0, and if we have less frequency than required, then it will be less than 0. So if it is less than 0, then it is not valid. So I will make this false and break this loop. Cool. And then I will just simply return this one. The time complexity will be n, and log of q base 2, and it's actually not let me write the exact time complexity. So it is a log of or I can write in this way, yeah, n plus m, where n is the text size and q is the pattern size, and the log of q base 2, where q is the number of queries that we have. This is the time complexity. So I guess we are good to move to the next problem. Just write a quick plus one if this part is clear to you. So I guess we are ready to move, and basically we are ready to solve the most difficult problem of the contest. And basically the final problem of this contest. After this, we'll wrap up the session definitely. So this is the problem that we have. You have given an integer array ARR of length n, and you have to perform q queries on this array. The query is of two type. The first query of type where you have to update the range. So for the first type of query, you will be given four integers. The first integer is 1. It simply represents the type of the query. If it is 1, then the first type of query. If it is 2, then the second type of query. And then three more integers, L and R, and X. So you have to add X to index L, then minus X to the next index, that is L plus 1, and again X to index L plus 2, then minus X to index L plus 3. Basically, this is alternatively. And then up till index R. So you have to add plus X minus 1, and so on, alternate values. So this is the first type of query where you have to update the range. Then the second type of query where you have to answer the range. That is, what is the value, what is the sum of indices, and not exactly the same, but basically plus minus alternate values, alternate operators we have. So you have to answer, that is, answer this expression ARR of L, that is what is the value of index L, then minus the value at index L plus 1 plus the value at index L plus 2, then minus the value of index L plus 3 up to R. This is also alternatives. So let's see how we can solve this interesting problem. So Zigzag queries. So for this problem, the prerequisite is a segment tree with the lazy propagation. And if you are not aware of this advanced topic, then please skip this solution. And once you learn the topic, then again come back and watch the video. So Zigzag queries. So for this problem, the prerequisite is a segment tree and with the lazy propagation. Lazy propagation. And this segment tree with the lazy propagation has two very important features. The first one, it support range update, supports range update in a logarithmic time, in log of n base 2, where n is the size of the array. That is, let's say this is the query, this is the array which is given to you, array ARR. And if you have to update some particular range with some specific values, so L to R, then this with the help of the segment tree with the lazy propagation, you can easily do this operation in just logarithmic time, and then answer range in also logarithmic time. So you can also answer the values of some particular range in just logarithmic time. So yeah, this is the feature of a segment tree with the lazy propagation. Now let's see how we can solve this problem. And now from here onwards, I'm expecting that you guys know about this segment tree with the lazy propagation. So let me write the array here. So let's say we have array, and also let me write some random values, 5, 3, then let's say 7, 8, 10, 12, 3, 4, and let's say 2. Cool. These are the values we have. And also let me write the indices. So index 0, these are the indices, index 0, then index 1, index 2, 3, 6, 7, and 8. Cool. That is, here the value of n is 9. Indexes from 0 to 8, 0 to n minus 1. Cool. So the idea here is to break this entire array into two sub arrays, and basically two parts. And the first one is for the odd indices, and the another one for the even indices. So for the odd indices, I will just simply separate out the values which are at odd indices. So this is my odd array, and it will simply store the values which are at odd indices. So odd index we have 1, 3, 5, then 7. These are the values at odd indices. So 3, then what we can say, yeah, then 7. Okay, not 7 but 8. Then at index 5 we have a 12. Then at index 7 we have 4. Cool. These are the values at odd indices. Then another array for even indices at audio quality. Okay, let me just quickly check. Just 1 minute. All right. So now let's just get back to the solution. So then at even indices, what are the values at even indices? We have 5. The value at index 0. 0 is a even number. Then 7 at index 2. Then 10 at index 4. And then 6 at index, what we can say, index, sorry, 3 at index 6. And then at index 8 we have 2. Cool. These are the values we have. And then what I can do, I can also write the indexes of these things. So this is index 0, then index 1, index 2, index 3, and index 4. Cool. So let's say the query, you are given some query from 2 to 6. So let's say this is the query that we are given, and 2 to 6, and here you have to update its value with x. That is at index 2 you have to add x, and here you have to subtract x, then again add x, then subtract x, and so on. Cool. So to break this query, I will just simply subtract, I will just simply get what are the indices which are contributing in the current query and are odd, and what are the indices which are even and are in the current query. So this is L and this is R. So to get this thing, what I can do, I can just simply say I can use two variables, odd start and even start. So I can use a variable, odd start and even start. So what will be its value? So it is just simply equals to L by 2, because this is these two indices will be at, these two values will be at index 0, and the first one is it is at index 0 of even array. Then the second index will be index 0 of the odd array. Then these two will be the will be at index 1, because this will be at index 1 of even array. Then this will be at index 1 of odd array. Then similarly these values would be at index 2, this index 4, which is even. So this 10 will be at index 2. So this is 0, 1, 2, basically dividing it in the chunks of 2. And just 1 minute. So then we have index 4 and 5. So index 4 will be at index 2 of even array, and index 5, that is value 12, will be at index 2 of odd array. Cool. So dividing it in a chunks of in a chunks of 2. Cool. So this simply gives you the starting index of odd and even array, which is simply equals to L by 2. But there is an edge case, L by 2. L by 2, and this is also equals to L by 2. So if the value of let's say L is 5, if the value of L is 4, if the value of L is equals to 4, so what does it mean? What is L by 2? So L by 2 simply means 2. So this is a start index, that is, this is the first odd value, even value. This is the first even value, and this is the first odd value. The idea here is to divide this array into odd and even indices. So this is simply equals to odd. Basically, this is simply equals to L by 2. But this is the case when the value of L is even. When the value of L is even. For example, here in this case, the value of L is 2. So from 2 to 6, basically this is the range. From 2 to 6. So here in this case, the value of L is even. So L by 2, which is equal to 1. So this is the index, that is a starting index 1 from the even array. This is the starting index 1, basically this one, value 7. Cool. Value 7 starting index 1 in the even array, and starting index 1 also 1 from the odd array. From the odd array, that is 8, the first odd value, odd index value, which is 8, and which comes in this query. So what I can do, if it is even, then it's fine. But in case if it is odd, then we have to make some changes. So in case if it is odd, because here the range, here these values start from an even index, that is first we have 0 1, then 2 3, then 4 5, it starts from even. So in case if it is odd, let's say the value of L is 3. So in case if the value of L is 3, this is the value of L is equal to 3. So then 3 by 2, 3 by 2, which is equal to 1, its floor value is equal to 1. So from for odd index, for odd, it start from value 8. For the odd array, it start from value 8, that is index 1, which is fine. But in case of even, it's not start from 1, because 1 is not the part of it. 1 is not a index 1, which is value 7. Value 7 is not a part of the current query. So we have to start from L by 2 plus 1. So if the value of L mod 2 is equals to 0. So if L mod 2 is equal to 1, then we have to start, even start would be L plus 1 and L by 2 plus 1. Cool. Basically, this is the first even index. First even value, first value which is at even index is 10. So that's why we have to update this. So I hope you get this thing. So once you get this information, now we have to find the value of odd end, where my odd index value will end, and then even end. So this is simply equals to R by 2, but again there is some edge case R by 2, and this is also equals to R by 2. Cool. Because with the same logic I can get the value. So let's say the query is from 2 to 6. Let me draw the query. So 2 to 6, and then let's say this is the value of R. This is the value of R. So if it is even, if it is odd, so let's say, let me just quickly write for this one also. So this is for 3, that is a 6 by 2 and 7 by 2, both will give you 3, and basically same as our requirement, because 6 is at index 3, not 6, but yeah, value 3. So value 3 is at index 3, and value 4 is also at index 3. Here you can see we have at index 3. Cool. So then, and yeah, what is an edge case? If it is the odd, what I'm trying to say now, please try to pay more attention. Here the value of R, which is equal to value of R, which is equal to 6. If it is even, then we have to make some changes. But in case if it is odd, let's say instead of this thing we have a value of R as 7. So if the value of R is 7, then it's fine case, it is an happy case. And here if it is an happy case, then I can just simply say the value of odd end, which is R by 2, and the value of even end, which is also R by 2, and this is an happy case, and I do not have any problem as of now. But once, and why it is so, so here the value of R by 2, basically the last even element and the last odd element. So r by 2, that is a 7 by 2, which is equals to 3. So that is true as well, because this is 4 and this 3, but both are at index 3. So here you can see both are at index 3, that is r by 2. But instead of saying, instead of this odd, if it is even, what if this is even? What is the value of what if the value of r is even? So let's say we have the value of r as 6. So in that case, your this formula will not work, because it is from left to right, and if I consider r, then it is from right to left. Cool. So that's why we have to, there is some edge cases. So if the value of r is even, so in this case, the value of r, which is equal to 6, and 6 divided by 2, which is equals to 3. So the first element which is at even index is this one, this element 3. But this 4 is not the part of the query. This 4 is not part of the range. This even the first odd index that we have is 5, and in the range that we have 5, and the value is 12. So this 12 is a part of the range. This 4 is not a part of the range. So in this case, we have to just simply subtract 1 from here, that is r by 2 minus 1. So this is the edge case that we have. If r mod 2 is equal to 1, that is, if it is odd, then it's an happy case. But once it is, if it is 0, then the first odd index element would be at index r by 2 and minus 1. These are the cases that we have. And once you have just simply remove the odd and even index element, and once you get the starting and end index of these array, then you can just simply use a segment tree with a lazy propagation for the range update and for the range answer. And one more thing, in my implementation, I am assuming that range starts from even index, even index. So that is, I will add plus x to all the even indices, and I will subtract x from all the odd indices. But there is a case, I have just used one extra variable. If it is start from odd index, if the range starts from odd index, then I will just simply multiply x with the minus 1. I will just simply change this x to the minus 1, so that at even indices we are adding minus 1, and at odd indices we are adding plus 1, that is minus x and minus x, which is equal to plus x. So what I'm trying to say, let me explain you with this one. So let's say the range that is given to me is 2 to 6. So this is an happy case. I have to add plus x here, minus x, plus x, and minus x, and so on. But if there is a case where the starting index is odd, that is the value of L is odd. So let's say here, if the value of L is odd, then what I will do, I will just simply multiply x with minus 1. So that is here we add minus x. Cool. And basically, and here I will just simply add minus x, then minus x. So it will eventually convert it into plus x. That is, here I'm adding plus x at odd indices, which is same as our requirement. So plus x, then minus x, then plus x, and minus x, and so on. And I hope you get this point. This is basically simple math. I have just multiplied with minus 1. So yeah, this is the complete explanation. Let me just show you the implementation here. So before showing the implementation, let me just plug in the charging. All right, so yeah, where we are. Let me just quickly. Yeah. So yeah, now I have to explain the implementation. So this is my segment tree template. I'm using the struct, but you can also use the class. So then long n, that is the size of the segment tree and the size of a lazy propagation array. Then here I am having initialization method, not method, but a function. Then here I'm having build function. This is a basic segment tree with a lazy propagation template. I'm not going to explain you this because this was a prerequisite. Then here I'm having this odd array and even array. Then if the index is odd, then I will add its value at in even array, and otherwise in a odd array value. And then here I have created two separate segment tree, one for the odd position and another one for the even position. Then I have initialized both the segment trees with odd and even arrays, and this is my answer array, and I iterate over all the queries, and for every query this is the type of the query, then a value of L and R. So then this is the left block, that is what is the starting and ending index in odd and even arrays. So L by 2 and R by 2 will be the ending index. So odd start block left and even start is block left, both are L by 2, and similarly odd end and even end would be R by 2. Then here I having the sign because I'm assuming that a starting index is even, that is L is even, and in case if L is odd, then I will just change this sign to the -1, so that when I will multiply x with the sign, then it will be changed accordingly. So if L is odd, then even start would be L plus 1, that is L by 2 plus 1, and change this sign to the -1, and this is the case for odd and even end. And if R is even, then we have to change this odd end to R by 2 -1. Yeah, these are the cases that I have explained, this one. And then it is, if it is of type 1, then we have x and multiply x with the sign. And if even start is less than or equal to end start, then I will just simply add x from even start to end start. And why I'm checking this condition, because there might be the case when the range is of when range only have one index, either odd or even. So in that case this condition will be false. There might be the case when the value of R and L both are same, that is the range only contains one element. So in that case the value of even start would be greater than the value of even end if it is odd index. Then yeah, similarly I'm checking for this one. I'm checking for this thing, and adding value minus x over this range. And how I will answer the query, this is my total, and then the sum of even indices, then the sum of odd indices, and again I'm checking for the same, and then asking for this query, and then again I'm asking for this query. And if it is, it starts from odd index, that is sign is 1, then it means we have to subtract odd sum from even sum. Cool. If the sign is 1, that is the starting index is even, then we have to add even sum and subtract odd sum. And if the sign is a -1, then it simply means we have to subtract the even sum from the odd sum, and then I'm adding this total in my answer variable. Cool. And finally I'm returning this answer. And how much time will it take? Now let's just discuss this thing. So first of all, I'm building the array, so that would take n log of building a segment tree, that would take n log of n by 2 times. And then we have q queries, and we are asking some range values, so that would also take logarithmic time. So log of n by 2, this is the time complexity we have. So I admit the last problem was the most difficult one, for which the definitely the prerequisite is a segment tree with a lazy propagation. And this was all from my end, and the complete explanation of all the 4 problems of last weekly contest 177. And hope you guys have learned something new. So make sure to write down your comment in the comment box. That would help me to improve the upcoming sessions. And I guess no doubt so far. In case of any doubt, you can go ahead. Otherwise, we can wrap the session. Cool. So we are good to wrap the session. Thank you so much, guys, for watching this stream, and have a good day.